Hi, today we're going to be doing completing the square, and if you need some review on that, this will be a good tutorial for you. Completing a square. Let's start off by an example here. Well, before we start though, I want to tell you where it's used quite a bit. It's used in conics section of Algebra 2, which is quadratic functions, ellipses, hyperbolas, as well as circles, to get it into standard form, or sometimes the books call it vertex form. Another time that you use the completing a square is to solve quadratic equations. So I'm going to give you a real simple example. X squared minus 6x minus 3 equals 0. The first step we do is we move the 3 to this side of the equation, the right side. So how do you get rid of the minus 3? We add 3 to both sides. You get x minus 6x. I'm sorry, it should be x squared. Notice it's quadratic here. It's a trinomial as well. Plus something equals, what do you have on the right side? 3 plus something. Please write both of them in. I know it's a little bit additional work, but it'll actually help you to focus on making sure when you add to the left side of the equation, you're adding to the right side of the equation. The equations are still balanced then. So how do we complete the square? We take this negative 6, the coefficient of the middle term, and then divide it by 2. Negative 6 divided by 2 is 3, and then square it becomes 9. And then add 9 to both sides. The equations are still balanced. Well, let's take this out for now. How do we factor the left side? First step is we put a square right there. What's the square root of x squared? It's going to be x, and then drop the minus, and then what's the square root of 9? 3. And then on the right side is 9 plus 3 is 12. You just completed the square. Okay? We still have to solve for it though. Take the square root of the left side, square root of the right side, square root of the square root, they cancel each other. X minus 3 is equal to, if you cancel both sides and take the square root, you have to put plus or minus. And then the square root of 12 is 4 times 3 on the inside. The square root of 4 is 2. It's a perfect square, 2 root 3. In fact, we can take out the parentheses, right? Sorry, you can't do that, you have to use your erasers. Add 3 to both sides, you get x equals 3 plus or minus 2 root 3. That's your answer. You can use the quadratic formula, which is negative b plus minus b squared minus 4c over 2a, or you can just complete the square. One thing to notice is that the leading coefficient here is 1, and the middle term is even. Completing square is a very effective and simple method instead of cranking it into the quadratic formula. So that's one way to solve out a quadratic equation using completing a square method. And it's also used quite a bit in conics, so learn and keep this in mind when you're trying to solve out for quadratic equations. Notice also that this is not factorable. Factorable means this way, it's not factorable at all, so that's why we're using the completing the square method. Example number 2 is a little bit more difficult. 2y squared plus 2y plus 5 is equal to 0. This problem, you have a problem with this, which is that 2 right there. The leading coefficient is not 1. So what you have to do is divide it by 2, divide by 2, divide by 2, divide by 2. And you get y squared plus y, 2 divided by 2 is 1, plus 5 halves is equal to 0. 0 divided by 2, notice the 0 in the numerator, that means this fraction turns out to be 0. Then we do the same cookie cutter process again. We move this to the right side, and then with y squared plus y plus something equals negative 5 halves plus something. Don't forget to put this in here and here so that you know that when you're adding, completing a square on the left side, you also add it to the right side. Again, the equations will be balanced then. You take the coefficient here. What's the coefficient in front of the y? It's obviously a hidden 1, right? And then divide it by 2, so it's 1/2. Square that, becomes 1/2 squared, which is 1/4. Notice that 1/2 squared means 1/2 times 1/2, which is equal to 1/4. So we're going to add 1/4 to the right side. And then completing squared, we're going to factor it. Square root of y squared is y. Drop the plus. And square root of 1/2 squared is plus 1/2. Equals, I forgot to put the square there. This one is not that bad. This turns into a 10 and a 4. So negative 10 fourths plus 1/4 is negative 9 fourths. Let's put this over here and work the rest of it out. You end up with, and you take the square root of both sides. The square and the square root cancel. You end up with y plus 1/2 is equal to plus or minus the square root of 9 fourths is the square root of 9 over square root of 4, which is equal to 3 over 2. But you have a negative inside. Oh, what's the square root of a negative? It's an imaginary, so take your eyes out. Take your eyes out. So this turns into an I times 3/2. Or I like to put my eyes in the back. Put your eyes in the back. So it'll be y plus 1/2 is equal to plus or minus 3/2 I. Subtract 1/2 to both sides. You get y, cross it out, is equal to negative 1/2 plus or minus 3/2 I. And then condensing those two becomes negative 1 plus or minus 3 I over 2. Notice that the I in the middle means it's in the numerator, not the denominator. So we can actually put in the numerator back in. That's your answer, negative 1 plus or minus 3I over 2. Good luck. One of the problems with this is when you have a leading coefficient of 2, you have a problem. And then when it turns into an odd number here, you're gonna be dealing with fractions. So when you have a leading coefficient 1, it's great, but when it's odd, completing a square is a little bit more difficult. I probably use the quadratic formula. Okay, good luck everyone.